Alright, this video is about how to find the values of the 6 trig functions given a point in space. I have put a reminder on here just about what some of the kind of key ideas were. So in order for us to do this, we need to know these 6 definitions for our trigonometric functions on the circle. That being said, as long as you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and that these features over here, cosecant, secant, and cotangent, are the reciprocals of those, then you're in pretty good shape. You can get yourself to this point. The idea now is that for us to do this, we need to be able to take our point and put it onto the coordinate plane. I'm going to ignore the grid on the back of this diagram, but the idea is there is some point. So if I plot the point 2, 4, so I'm going to pretend that it's right around there. And this is now the point 2, 4. That point exists on some circle. I'm pretending this is the circle that it would fall on. Any point I plot in space, there is some circle that point would fall on. The radii of those circles would be different, but every point would fall at the end of some radius. So we're going to talk about the circle that has this particular radius. So I'm going to draw the radius in, and this is our radius for this particular point, for this circle. Once I draw my point, my next step is going to be to go ahead and to draw a reference triangle. So we know that reference angles go from the terminal side to the closest x-axis. So my reference triangle is also going to go to the closest x-axis. In this diagram, we're going to say that the reference angle is at the origin to the closest x-axis. It will always be there regardless of what quadrant we're in, which is a nice commonality. And in this diagram that I've drawn, I see that 2 is this distance right here. It's how far I've gone to the right. So this is my 2 length, that's my x. The height that goes up and down from the x-axis would give me my y value. So this is 4, which is my y. And then the third side of this triangle is our hypotenuse, which is the radius of our circle, and that is not given to us. So before I can proceed, I need to determine what the radius is. There may be other circumstances where I know the radius in either the x or the y. In those cases, I would find whatever the third piece of missing information is. And because these are right triangles, the way that we'll do that is by using the Pythagorean theorem. So I'm very quickly going to say that 2 squared plus 4 squared equals r squared. So I get 4 plus 16 equals r squared. I get that 20 is r squared. So r is the square root of 20. But it is, as always, good practice for us to take that and simplify it. I know that this is 4 and 5, which is 2 and 2. There's a pair of 2's under my square root. So my radical simplifies to 2. I don't like how that looks. Let me fix that here. My radical simplifies to be 2 times the square root of 5. That's the radius of my circle. So up in this diagram, we know that this side length here, I'm going to take away r for a second and put it back on. This radius is 2 times the square root of 5. That's my r. So now, if I come back to these definitions of my circular trig functions, we have y, we know r, and we know x, and that's all that I need for any of these. So now it's time for us to go ahead and write those 6 trig ratios. So the sine of our angle, which I don't know what it is, so I'm just going to say sine theta, is y over r. Y here is 4, r here is 2 square root of 5. That's a pretty good start. However, we can see that that is simplifiable. I can reduce the 4 with the 2, so I want to do that. So I'm going to say that this is 2 divided by the square root of 5. And then last step is to rationalize. I can't leave a radical square root in my denominator. So I'm going to say that the sine of this theta is 2 square root of 5 over 5. While I am here, I'm going to do its reciprocal as well, because I like to think of them in pairs. So sine is not a cofunction, so it needs a cofunction for its reciprocal. So its reciprocal is cosecant theta. And in cosecant theta, I want to take the fraction from sine and flip it upside down. I'm going to choose to use this version of the fraction for sine because it has the radical in the denominator, so when I flip it over, the radical will be in the numerator, and that's what we want. So I'm going to say that cosecant theta is equivalent to 2 square root of 5 over 4. And now I can move on to my next pair of functions. Next up will be the cosine of theta. That's x over r. So I look at my diagram, the x value is 2, the r is 2 square root of 5, and again reduce, that gives me 1 over the square root of 5, and then rationalize in the same way. So I get the cosine of theta is the square root of 5 over 5. And its reciprocal, that is a cofunction, so its reciprocal must not be. So its reciprocal is secant of theta. And again, I want to choose to flip over, take the reciprocal of the step where the radical's in the bottom, so that was that guy right there. So I get 2 square root of 5 over 2, and of course I just realized that that can be reduced, which makes me think that in the previous function I can do the same thing. So I'm going to pack up here for a second. This is actually the square root of 5 over 2 for the cosecant value. Our last pair is tangent and cotangent. So the tangent of the angle is equal to the y divided by the x. The y value here is the 4, so I get 4 divided by, the x value is 2, and that again reduces. So the tangent of this angle is 2. The cotangent, which is its reciprocal, would end up just being 1 over 2. And those are the values of the 6 trig functions given a point in space. So again, keys being to plot the point, draw the radius that point would fall at the end of, draw on the reference triangle, labeling where the theta is, label 2 of the 3 sides of the triangle, use Pythagorean theorem to find the length of the third side, and then after that, using the 6 trig function ratios to write the ratios we're looking for, and then lastly, in each of those steps, making sure that we are reducing and then rationalizing for our final answers.